Greetings. In last video lecture, we have discussed about digital to digital conversion. In that, we have discussed about line coding techniques, block coding techniques, and scrambling techniques. So, in this video lecture, we are going to discuss about digital to analog conversion, like analog transmission, how digital data is converted to analog data and how it is transmitted in the transmission medium. That technique we are going to discuss in this video. This topic under Unit 2 in computer network, digital to analog conversion. Okay. This is classroom discussion topic 12. So, lecture outcome. After listening to this video lecture, you as a student will be able to interpret digital signal into analog signals using shift keying techniques. So, what is digital to analog conversion? It is the process of changing one of the characteristics of an analog signal based on the information in digital data. If we have the digital data, how we are sending the analog signal according to the data, how we are changing the information in the analog signal according to digital data. Okay. So in this video lecture, we are going to discuss about these techniques like amplitude shift keying techniques, frequency shift keying techniques, phase shift keying techniques. Three keying techniques is there for converting digital data into analog signals. Okay. So what is digital to analog conversion? Digital data needs to be carried on an analog signal. So whatever the form of data, it may be sent as an analog signal in the transmission medium. Already we know that. Okay. So for that we need a carrier signal. What is carrier signal? Carrier signal or carrier frequency, we can say both are same. Okay. So frequency f of c means carrier frequency. We can say the carrier signal as carrier frequency also. Performs the function of transporting the digital data into analog waveforms. Okay. So the carrier signal is used to transport the digital data in an analog waveform. The analog carrier signal is manipulated to uniquely identify the digital data being carried. So how we can send the data? We know digital data may be represented zeros and ones. Okay. So how we can represent one in the signal forms? How we can represent the zero? Like how we are representing the signal according to conversions, we can transmit the data in the transmission medium. So this is the diagrammatic representation for digital to analog conversion. So we have the digital data, then we need the analog data for transmit in the link. Link means transmission medium. So we have to convert digital data into analog signal. For that we are using modulator. The modulator is used to convert the digital data into analog signals. Okay. So for converting digital to analog conversion, like digital data to analog conversion, we have three variants based on the amplitude, that is amplitude shift keying techniques. Based on the frequency, it is frequency shift keying techniques. Based on the phase, it's a phase shift keying techniques. So the combinations of ASK and PSK, that is quadrature amplitude modulation is there. QAM method also is there. In this video lecture, we are going to discuss about these three methods. Okay, so already we know what is amplitude, what is frequency, what is phase. So when we are saying about the transmission, we must know bit rate and baud rate. Okay, bit rate means number of bits transmitted per seconds. That is bit rate. Okay. So baud rate means number of signal elements transmitted per seconds. That is baud rate. Okay, that is modulation rate or signal rate or baud rate. Already we are discussed. How we can calculate that baud rate or bit rate? Okay, so signal rate. Signal rate means S equal to N into 1 by R. N equal to number of bits. Okay, R equal to ratio between the signals and data. Okay. In this example, you just see here that an analog signal carries 4 bits per signal elements. 4 bits per signal elements. That means 4 by 1. Okay, 4 data per 1 signal elements are equal to 4. Then if 1000 signal elements are sent per seconds, okay, find the bit rate. So what is the bit rate? So already we know the formula. Here S equal to N into 1 by R. So now we can convert the number of bits. We know that is signal rate. So here R equal to 4, S equal to 1000. So N equal to unknown. So what we have to do, we can change the formula equal to N equal to S into R equal to 1000. Okay. So what is R value? S value is 1000, R value is 4. So 4000 bits per second. That is the data rate. In example 2, you just see here an analog signal has a bit rate of 8000 bits per second. Okay. So what they are saying that bit rate they are given. N value. Okay. N value equal to 8000. And baud rate is equal to 1000. So what is the formula? Already we know that S equal to N into 1 by R. So here they are given S value, N value. So what we have to calculate, how many data elements are carried by each signal elements. That is the ratio we have to calculate. How many signal elements do we need? Okay, these two questions we have to answer it. So now we know that S equal to, what is the S value, signal value? That is 1000. Okay. So now we have to calculate the R value. So R equal to, this R will come this side and S will comes to this side, N by S. So what is the N value? N value is 8000 and S value is 1000. So totally 8 bits per baud. So each signal we are sending 8 bits. So what is the level we require? How many levels are required? We know that. Okay, so L equal to 2 power R. So R equal to 8 and 2 power 8 equal to 256. So we need 256 levels to transmit this data with this bit rate and signal rate. Okay. So now we are going to discuss about first method, amplitude shift keying techniques. What is ASK? ASK is implemented by changing the amplitude of a carrier signal to reflect amplitude levels in the digital signals. Okay. So carrier signal means it's a carrier frequency. That's a signal have some amplitude with the same speed, and then wherever we want to change the signal, we can change according to the digital data. That is modulation. Okay. So here we are using that amplitude based shift keying techniques. So example, what they are saying, if the digital equal to 1 would not affect the signal. So whatever I am sending the signal, so the signal is like this means it is not affected if the value is 1. So then, whereas a digital is 0, the digital data is 0 means by making it 0. So there is no signal. Okay. So if it is 0 means what I have to do? There is no signal. So this point up to this point, there is no signal. So after in case 1 means then same signal will be there. Okay. So this is amplitude shift keying techniques. Here what we have to calculate? So we have to calculate the bandwidth of amplitude shift keying. Okay. So here bandwidth in calculated using B equal to 1 plus D, yes. Okay. So here what is the D value? D value may be between the 0 and 1. Okay. So 0 means the values may be in the same signal values, or if 1 means 1 plus 1, 2, yes. Okay. So bandwidth may be 2 times of signal elements. So the minimum is single yes. Okay. Maximum is 2 yes. Okay. So the bandwidth is based on the signal elements, or maximum is 2 to the 2 times of signal value. See this diagram. So already I told, for 1 is there, this is the digital data. For digital data, the frequency whatever we are sending here, carrier frequency, that will be passed here. Okay. So here what is the frequency of this signal for representing 3 bar. Okay, so here 3 bar. Like frequency, when we are saying the frequency, it is 3. Okay, 3 hertz. So 3 hertz will represent one digital data. So here also 3 hertz, here also 3 hertz. Wherever 1 is there, the same signal will be there. But wherever 0 is there, there is no signal. Okay, so that is the amplitude. Amplitude is 0. Where 1 is there, same amplitude will be there according to carrier frequency. If amplitude is 0 means there is no signal. Amplitude is 0. So this is called like amplitude shifting techniques. Okay, wherever 1 is there, the signal will be there. Wherever 0 is there is no signal. Okay. Then we know that R value. What is the R value? R equal to 1 data, 1 signal, 1 by 1. R equal to 1. So then signal rate equal to N into 1 by R. Okay. R value equal to 1 means the signal rate equal to same bit rate. So bandwidth equal to, we know that already 1 plus D. Yes. So we are sending the frequency, carrier frequency. Same frequency will occupy the entire bandwidth. Okay. So this is the implementation, how we can generate that signal. So whatever I said, we are sending the carrier frequency, that is carrier signal. So this is the digital data. Then what we are doing this, when we are doing this, so this method you will see here. So digital data is coming like this, and oscillator is generating the carrier frequency. So the multiplier will multiply with wherever 1 is there, the signal will be passed. Wherever 0 is there is no signal. Okay, so here you will see this 1 value, there is a signal. So final output modulator signal is waveform is there. Here 0 is there, but here waveform is there, but 0 means it will be converted to 0 signals. So here also 0, there is no amplitude. This is amplitude shifting technique. So you just read this example. We have an available bandwidth of 100 hertz, bandwidth equal to 100 they are saying, which spans from 200 to 300. Okay, so how we can say that bandwidth? So this is the bandwidth. So this is 200 to 300 they are saying. So the total frequency is 100. Okay, maximum value to minus minimum value. So 300 minus 200, that is 100 kilohertz. Okay. So here, what are the carrier frequency and bit rate if we modulated our data by using amplitude shifting with D equal to 1? Okay. So what is the formula? So we know that D equal to 1 plus D into S. Okay. So equal to what they are saying that D equal to 1 they are saying 1 plus 1 2. So 2 into S value. Already we know S value. What is the S value? N into 1 by R. Okay. So R value here they are given already. One data, one data signal. So 1. So 2N values. So 2N equal to 100 kilohertz. Already we are mentioned. What is the bandwidth? 100 kilohertz. So 2N equal to 100 kilohertz means N equal to 100 by 2 kilohertz. So that will be converted into 50 kilobits per second. That is the bit. So next one is the frequency shifting. In amplitude shifting, there is no amplitude while the data is 0. Okay. In frequency shifting, just see this. If the value is 1 means could be represented F1 equal to carrier frequency plus delta F. Okay. So here in case 0 means could be represented by F2 equal to carrier frequency minus delta F. Okay. So like that, the frequency changes will be there in the frequency shifting technique. So here you will see this for representing this 1, 1, 2, 3, 4, 1, 2, 3, 4. So 4 heads. Okay, this particular 4 heads is representing 1. So here 1, 2. Only 2 heads representing 0. So like this, here 4 heads, here 4 heads, then here 2 heads. Okay, so how many full period of signals are transmitted? I'm saying. So actually, per 1 seconds, how many data signal transmitted? That is frequency rate. But here, this is the period. Okay, so how much full a waveform is generated. That is represented. So wherever 1 is there, high frequency is there. Wherever 0 is there, low frequency is there. Okay. So how we can calculate it here? So already we know that bandwidth equal to S into 1 plus D. But here, two extra form we are using. S1 plus D, S1 plus D. So this is one frequency, this is one frequency. For this frequency, S into 1 plus D. For this frequency, S into 1 plus D. Okay, so finally they are calculating is 2dF for these two frequency. Okay. So when we are thinking about the frequency shift keying, the bandwidth equal to 1 plus D into S and 2 delta F. So we know that what is 2 delta F. Delta F means one is whenever one is the F1 and F2 is there, no, that adding it, finally we are saying 2 delta F. So see this example. In this example, we have an available bandwidth of 100 kilohertz. Same examples, okay, 100 kilohertz, which is spanned from 200 to 300. Okay, so this is the timeline. This is the frequency we are representing. The minimum value 200 kilohertz, maximum is 300 kilohertz. So the frequency is 300 minus 200, 100 kilohertz. Okay. So which span the already we are mentioned. What should be the carrier frequency and bit rate if we modulated our data by using FSK? The previous example they are using amplitude shift keying, ASK. Here they are asking frequency shift keying. So here what we are adding it extra 2 delta F will be added there. Okay. So what they are saying, B equal to 1 plus D into S plus 2 delta F equal to 100. Already they are given the value is 100. Okay. So now we have to calculate D equal to 1. Already they are given D equal to 1. So 2S into 2 delta F. Okay. So here in case what is the value? If 100 means 2S equal to 50. Okay. 50 kilohertz. So then S equal to 25 kilowatt. So what is the bit rate? It is 25 kilobits per second, 25 kilowatt, because D equal to 1. Coherent and non-coherent. What is non-coherent? When we change from one frequency to another, we do not adhere to the current phase of the signal. So we know that phase signal, okay, so it may be like this. Here it is there. We are not changing the phase. It will be continue, then it is considered as the non-coherent. Okay. The switch from one frequency signal to another signal only occurs at the same phase in the signal. Okay, so that is coherent values. So multi-level frequency shift gain techniques. So similar ASK and FSK, we can use multiple bits per signal elements. So if we are sending multiple bits means, what is that? We need to provision for multiple frequency in the each representative proof of data bits. Okay. So that means what is it? In frequency, we are sending one frequency is high frequency, another one is low frequency. So we need to separate frequency level for sending the data in frequency shifting techniques. Here you see there actually for one, this is a frequency level. Okay, the carrier frequency FC. So if we are adding delta F, okay, the plus value for one means we have to add delta F. Okay, so what is the delta F? 2F value. Okay, it may be 2, here it may be 4. Okay, so here whenever it is coming like this, then it will be minus. Whatever the frequency, carrier frequency is sending, the same data will be there because minus del F from the previous one. So then here plus del F from the carrier frequency, like that it is generated. For that, what we need for frequency shifting techniques, voltage controlled oscillators. Okay, so this tool is required for converting digital data into analog signal with based on frequency shifting techniques. So finally, phase shifting techniques. Okay, so already we know the phase value we are mentioned in degrees and radians. So here it's not affecting the signals. Okay, so the wherever the signals are there, there is no changes. Okay, only phase will be changed. So the bandwidth is same with amplitude shift keying methods. So because only it is changing the shift. Okay. So you see here, whenever one is there, it is going that blue color line. You see that blue color line. That is the waveform starting with 0 degree. Okay. Then here, what it will be there, 90 degree, it will be reverse, not 90 degree, 180 degree. Okay. So 180 degree, it will be reverse. So finally, we have the baud rate is 5 only. Within 1 second, 5 data bit rate we are sending. Okay. So for this, like binary phase shift keying method, it is similar like binary amplitude shift keying technique. So how we did for binary amplitude shift keying, same method we have to use. Like oscillator will generate the frequency, carrier frequency, and we are sending the data. Then multiplier will multiply with value. Whenever the 0 is there, then it will change the phase. Okay, that it's not changing the frequency value. Same frequency will be transmitted. So finally, quadrature PSK, phase shift keying. What is quadrature? To increase the bit rate. What is our ultimate aim? We have to send more data for simple signals. So we can code 2 or more bits into one signal element. That is called like quadrature. So we parallelize the bit stream so that every 2 incoming bits are split up to up and PSK carrier frequency. One carrier frequency of phase shifted 90 degree from the other in quadrature. So how we can do it? You see here. Okay. Here initially 0, 1, 0, 1. It is the data. For that it is represented this digital line coding techniques. We are sending the carrier frequency. So accordingly it will be there based on the phase. Okay, wherever the values are came, the phase will be changed. Okay, this is modulator signal. But another data we are sending 0, 0, 1, 1. So for that also we are using the line coding techniques. Wherever the 0 is there, it will send same value. But what happened here? Wherever 1 is there, it is changing to shift keying. You just see here 0, 0. Okay, here 0 is there, here 0 is there. Whenever we are representing 0, 0, the signal will becomes like this. Wherever the signal 1 and 0, 1, 0, we can send data like this. So this is the quadrature shift keying technique. Quadrature amplitude modulation is a combination of amplitude shift keying as well as phase shift keying techniques. So now we are in the end of this lecture. After listening to this video lecture, now you can interpret the digital data into analog signals using shift keying techniques. We know 3 shift keying techniques are there. Used on those shift keyings, you are able to convert digital data into analog signals. Here this is lecture level problems. An analog signal has a bit rate of 10,000 bits per second and a baud rate of 2000 baud. How many data elements are carried by each signal element? How many signal elements do we need? Okay, you just work it out for this problem and come for discussion in the class. Okay. So next classroom discussion topic is link layer addressing that we will discuss in the next video lecture. If any query is there, please post the query. You come with the solution for lecture level problems. Then we will discuss in the classroom discussion. Thank you very much for listening to this video lecture.